Welcome back. So I only have 4 slides left, and then I'm done bothering you with XML and JSON, at least for now, right? I wanted to say again something that we discussed during the break that is very important. What I would like you to understand is XML or JSON technically is the same thing. You really have to understand that these are both syntaxes for trees. They don't look the same, but logically, if you use the data-oriented XML and JSON, it is totally equivalent. My personal preference is for JSON because JSON tends to be a bit simpler and it's also growing in popularity. The only real difference that might drive some decisions when you're making decisions for a company is that depending on your use case, the XML ecosystem is a bit more mature than the JSON ecosystem. The only reason is that it started before. That's the only reason. It's been there for longer. And so the JSON ecosystem is catching up slowly. But eventually, I expect that you will have on both sides. So again, do not be too much biased towards the one or the other. Be open to both of them, right? And it really, really depends on the use case. There are use cases where JSON is absolutely fine. There's more use cases that might require more advanced tooling that XML already has, that in some cases might be preferable. All right? I hope it makes sense, right? So try not to be too biased one way or the other. If you see that both of them in the end are trees, then this is my goal. All right. So this is a flat table, and I wanted to show you next what happens if you have a nested table, because I already showed you in JSON, it's an arrays of objects that are nested. Well, here we just nest elements. And remember this thing with the plurals and the singular forms, right? That for the table, I have this plural form set with the singular elements repeated for every bracket. How do I do this? I have orders. Then again, I put my plural form in every bracket. And then I have these order sub-elements. So now you see, I have multiple levels of hierarchy, right? So this is why we say this is a tree. Who sees a tree now with this? Okay, who doesn't yet? Okay, you will in 2 weeks, because then we'll start drawing the trees and doing the data modeling, right? Okay. Now again, both are fine, and you can start a lot of trolls on the internet if you ask if you prefer the one or the other. You really, really should realize that they are the same on the logical level. It's just about trees and denormalized data sets. Okay. Now there is this other syntax that is also growing in popularity, and I don't know, maybe in 10 years everybody will throw away JSON and go into YAML. You basically never know. But you're ready for that, because if you look closer here, it's exactly the same features. You also see, for example, this something that looks like an array here with these dashes. You also see something that looks like a map or an object, right? So who would be able to write the JSON equivalent of that, right? It's pretty straightforward. So this is YAML. Of course, YAML has a lot of bells and whistles that JSON doesn't have. Sometimes you have several ways of doing the same thing. But this is pretty much what it looks like. So I'm not telling you anything more than that, because this is going to be easy. If one day one of you needs to work with YAML, just read the spec, look at documents, but you're going to be just fine. All right, so this is syntax. Again, syntax is when you want to just drop it on a data lake, put a data set for downloading, but above all for long-term archiving, because this is a textual format. So you know that in 100 years, in 1,000 years, if you store it, of course, on some storage medium like a crystal, or I don't know, people will still be able to read it, because they can still decode like the encoding, and then they'll figure it out. If you use a binary format, and PDF actually is kind of a big question mark there, because people realize that PDFs one day might become unreadable if we lose the libraries that open them. So believe it or not, there are institutions or governments that are moving from PDFs to HTML. And exactly for this reason. It's a text format. It's a bit safer in the very long term for archiving. All right? But I'll come back for the querying. For querying, maybe that's not a good idea to have them in this format, and we want to compress them in some more efficient formats. But that I'll come back to when we validate the data. Any questions so far? All good? Yes, over there.
It's just kind of a question regarding the point that you mentioned, archival. In an archival setting, would we actually compress these kinds of textual representations, or would we leave them uncompressed?
I can't remember. We can go to the website of the library. Basically, if you start compressing, this is already taking a small risk, because you need to make sure that you can uncompress. I can't remember if zips are allowed. We will look that up. The research collection at ETH has this kind of list of what you can do and cannot do. It might be that some formats they tolerate that you can compress. I just cannot remember if it's just some tarballs or if it can be compressed. I'll come back to you on that. Right? Can we make a note? We'll take a look at what the research collection is doing. Right? It's really about thinking about what happens in a century or 2 centuries, right? Because if we want to preserve things, we need to be careful. All right, should we go to the next course? Okay, let's do that.